Physical magnitude is a property of bodies and elements that allows them to be measurable and, in some cases, observable. Likewise, the quantities can be of two types, scalar and vector. Scalar quantities are those that can be represented through a numerical scale in which a greater or lesser degree of value is distinguished, as appropriate. For example, temperature, energy, time, among others. On the other hand, vector quantities are those that provide more information about the properties of a body or element. Therefore, it is represented through vectors that indicate a direction, a sense, and a magnitude that is measured by means of a coordinate system. For example, speed, force, acceleration. The fundamental quantities by convention are those quantities that cannot be defined as a function of any other, and all the others are derived from their units, and these are mass, length, time, intensity of electric current, temperature, the amount of substance, and the light intensity. Time is a quantity that is frequently used in physics, although it is not a property of an object. Rather, it is a property of a given situation or motion. Like all time-related quantities, such as velocity and acceleration, for example. Physical quantities are used to recognize and measure the properties of objects. It is necessary to be able to compare that object with another or with a particular situation. We can identify which object has more mass than another, which is smaller or larger compared to another. We can even compare something with itself, if the property we are measuring changes over time, such as the size of a plant when it grows. To measure is to compare things of the same kind. This means selecting one thing, called a unit, and counting how many times it is contained in something else of the same type. For the measurement to make sense, shared or equivalent units are needed. This is where the International System of Measurements was born. Since man trades, he needs common units. In the French Revolution, thinkers and scientists dream of putting into practice a universal measurement system. Thus was born the metric decimal system. In 1875, the meter convention is signed by 17 countries, being the first international agreement in the field of measurement science called metrology. At the beginning, the system consisted of three fundamental units: the kilogram, the meter, and the second. Science progresses, and in 1946, new units appear such as the ampere, in 1954, the Kelvin degree, and the candela. In 1960, the International System of Units was established in the 11th Convention of Weights and Measures. In 1971, the mole joined the other 6 units to form the system we know today. In the 20th century, 3 of the 7 units of the international system were redefined, according to constants of nature. In 1967, the second was redefined regarding the vibration of the cesium atom. In 1979, the candela was defined in terms of luminous efficacy. In 1983, the meter was defined with respect to the speed of light. For the first time in history, 4 units will be redefined at the same time. This allows the International System of Units to finally rest on 7 constants of nature. To determine the values of these constants, researchers have been working for decades in national metrology laboratories, developing various experiments. The Kelvin degree is defined with respect to Boltzmann's constant, the ampere with respect to the elemental charge, the mole with respect to Avogadro's constant, and finally in 2019 the kilogram is redefined with respect to Planck's constant, thus ceasing to be a physical reference.